All right, pull out your gold notes. Our first learning target is I can solve quadratic equation written in factored form. And our factored form is A times x minus p times x minus q equals 0. So again, we have been practicing factoring quadratic or algebraic expressions, right? We've been factoring expressions. Now we are going to be solving quadratic equations, and what we're going to use is our factoring skills today as one method for solving some quadratic equations. So first thing, you just had a slide ask you to do some mental math, and I bet you some of you kind of panicked a little bit when you saw all these numbers, and you probably thought, Mr. Plank, are you silly? Are you crazy? Why are you asking us to do all that in our head? But what I was hoping you discovered is you went 3 times -2, you had -6 in your head. -6 times 4, and you got 24, -24. And then you got -24 times 0, and you got 0. So then, as you kept multiplying, if you went that far, you went, oh, 0 times 54 is 0, times 137, 0, 0 times this, 0. So hopefully a lot of you did get that the product of that multiplication of all those factors is 0. So what we've learned back in the day is anytime one factor is 0, the product will also be 0. So this is called the zero product property. So a product of factors is 0 if and only if one or more of the factors is 0. So we can say if A times B times C equals 0, then we know that A is equal to 0, or B is equal to 0, or C is equal to 0. They don't all have to be 0, but we just know that one of those factors, either A or B or C, has to be 0. So why did I bring that up? Because we're going to use that now in solving quadratics using factored form. Here's our example. We have 3 times 2x minus 3 plus x plus 5 equals 0. So this is going to be factored form, and the key here, this is only going to work if it equals 0. So if this says 3 times 2x minus 3 times x plus 5 equals 10, we're not going to be able to use this method. All right, this method is only going to work when we have factors set equal to 0. All right, so some of you might be saying, well, Mr. Plank, is this quadratic? How's this quadratic? I only have x to the first degree. But remember, if we multiply the 2x minus 3 times the x plus 5, we're going to get a quadratic trinomial. And we can multiply that by 3, just a larger quadratic trinomial. So it is a quadratic. It's just in factored form. So first thing we're going to do when we have this form is we set each factor with the x variable equal to 0. So this has 3 factors, right? 3, 2x minus 3 is a factor, and x plus 5 is a factor. Okay? The 3 is a constant. We can't go, make 3 equal to 0. You can't do that, right? You can't set 3 equal to 0. So that one is just staying 3. That's okay, because we know if 2x minus 3 equals 0, then x plus 5 could be worth 10 billion. Doesn't matter. 3 times 0 is 0. 0 times 10 billion is still 0. It works, right? So we're going to go 2x minus 3 equals 0. And we're going to go x plus 5 equals 0. Our next step is now we're going to solve those two equations, right? So we add 3 to both sides on this first equation. We get 2x equals 3. Divide both sides by 2. We get x equals 3/2 or x equals 1.5. On the right equation, we subtract 5 from both sides, and we get x equals -5. All right, we're done. We solved it. Now we can check it, and we can check it using substitution, where we're going to substitute the 1.5 back into the equation for both x's and see if it works out to give us 0. So here's my work for the check. It's going to be 3 times 2 times the 1.5 minus 3 multiplied by the 1.5 plus 5 equals 0. Now I use brackets here because I was putting parentheses for what I was showing you the substitution work. That's why I use brackets instead of parentheses here. Then we get 3 times 0. Where do I get the 0 from? 2 times 1.5 is 3. 3 minus 3 is 0. And then The 6.5 came from the 1.5 plus 5. Inside the parentheses, that became 6.5. All right, well, 3 times 0 is 0. 0 times 6.5, 0. 0 equals 0, check. Other equation, we substitute the negative 5 in, same thing. So now we get 3 times negative 13. Where did negative 13 come from? 2 times negative 5 is negative 10. Negative 10 minus 3, negative 13. And then times 0, where does 0 come from? Well, negative 5 plus 5 is 0. So now check this one. You get 0 equals 0 because 3 times negative 13 is negative 39, but negative 39 times 0 is 0. So we get 0 equals 0. Again, I want to stress, this method will only work when the equation equals 0. So if you're ever given like 3 times 2x minus 3 times x plus 5 equals 7, cannot do this, right? The reason this works is because it's equal to 0, and we're applying the zero product property. So for this to work, you need to remember factored form must be equal to 0.